In Activity 8, Thunder and Lightning, students discover the origins of thunder and lightning and reproduce them on a much smaller scale in the classroom. Students first discover what causes lightning and thunder, then model lightning by generating static electricity and learn how to estimate the distance of a storm. Finally, students discuss ways to stay safe during a lightning storm. You will need the following materials from the kit: Activity Sheet 8, balloons, roll of aluminum foil, and lightning safety tips. You will also need to provide clock with second hand, pin, and a pair of scissors. To prepare for Session 1, cut a piece of aluminum foil about 6 centimeters by 30 centimeters for each student. Note that this session must be done on a very dry day, as static electricity may not develop if it's humid or raining outside. Also, for best results, conduct the experiment in a dark room. Then, make a copy of Activity Sheet 8 for each student. Each student will also need a balloon and a strip of aluminum foil. To begin Session 1, ask students if they've ever gotten a shock from touching something or someone. Answers may include feeling a brief tingling or prickly sensation, seeing tiny sparks, and so on. Then ask students, what do you think causes the shock and the sparks? Explain that the shock they felt and the sparks they saw were caused by electricity jumping from one object to another. Define electricity as the movement of electric charges, and explain that this is exactly what happens during a lightning storm, but on a much larger scale in the atmosphere. Help students understand that before a thunderstorm, electricity builds up in clouds, and that during the storm, this electricity is released as giant sparks, or lightning, in the sky. Electricity and lightning can jump from a cloud to the ground, from a cloud to an object on the ground, such as a tall building or a tree, or from one cloud to another. Ask students, what is the weather like before and during a lightning storm? Students should respond that lightning storms usually occur during the summer. They may recall the sky gets very dark before a lightning storm, and may also mention seeing cumulonimbus clouds. Help students understand that before a lightning storm, the air gets cooler and it becomes very windy. Soon after, it begins to rain, usually quite heavily. Point out that rain may turn briefly to hail. Next, distribute a copy of Activity Sheet 8, one balloon, and a strip of aluminum foil to each student, and instruct students to blow up their balloons. Then, guide students to fold over the aluminum foil lengthwise twice to make a long, flat wand. Explain to the class, if lightning strikes a building, it usually hits the tallest part of that building. In most cases, this is the lightning rod, which directs lightning away from the roof and sends it through a wire into the ground where it disappears harmlessly. Without a lightning rod to redirect the lightning, the building could catch fire. Inform students that the foil wand will act as a kind of lightning rod. Reassure students that while the foil rods will attract electricity like a lightning rod, the amount of electricity involved is so small that it can't hurt them. Tell students to create lightning, or static electricity, by rubbing the balloon against their hair for about 15 seconds, and then to slowly bring the foil lightning rod toward the balloon. Discuss students' observations. Specifically, ask if they heard a sound from the sparks they created. Students should recall hearing a crackling sound. Then ask, what usually accompanies lightning? Students will probably respond that they hear thunder, or a rumbling or a cracking sound that can be heard following a lightning flash. Let students know that the crackling sound they heard was like thunder, but again, on a much smaller scale. To conclude Session 1, collect the balloons, lightning rods, and activity sheets. Save the balloons and activity sheets for Session 2. To prepare for Session 2, make a copy of the lightning safety tips for each student. You will need a balloon and a pin for the classroom demonstration. You will also need a clock with a second hand that all students can see. To begin Session 2, blow up a balloon, hold it up in front of the class, and encourage students to notice that the balloon is filled with air. Pop the balloon with a pin and ask students what happened to the air inside the balloon. Students should have observed that the air escaped when the balloon popped. Help them realize that the sudden rush of air leaving the broken balloon caused the pop sound. Then, inform students that rushing air causes thunder. In this case, air around a bolt of lightning is rapidly heated, causing the air to rush away from the lightning very fast. We hear this rush of air as thunder. Ask students, during a lightning storm, which do you experience first, thunder or lightning? Students should say that lightning is usually seen before thunder is heard. Inform the class that thunder and lightning happen at the same time, but because light travels faster than sound, you usually see the lightning the instant it happens, and that it takes longer for the sound of thunder to reach your ears. Explain, for sound to travel 1 mile, it takes 5 seconds. For example, if 5 seconds pass between the flash and the thunder, the storm is 1 mile away. If 15 seconds pass, the storm is 3 miles away. Ask students to practice counting the seconds between lightning, a flickering of the classroom lights, and thunder, the popping of a balloon left over from session 1. Be sure to vary the interval and to record the number of seconds for each trial. Then, have students work in pairs to complete question 4 of the activity sheet. Next, remind students of the question you asked them about being shocked. Make sure they understand that while this small shock may be startling, the amount of electricity involved is too small to hurt them. Then, ask students, can lightning hurt you? Guide students to realize that lightning can hurt if it hits you, hits an object that you are touching, or starts a fire. Also mention that, fortunately, people are rarely struck by lightning. To conclude Session 2, distribute the Lightning Safety Tips sheet and review it as a class. Some students may already know the basics of lightning safety, but be sure to correct any false information. Finally, inform students that in the next activity, they're going to study a very severe type of weather that can develop during lightning storms. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.